Hey everybody, welcome to another episode where we answer some code questions dealing with the 2020 edition of the National Electrical Code. My name is Paul Abernathy, your host as always. If you're looking to learn the National Electrical Code or studying for an exam, check out our Fast Track system. Just go to fasttracksystem.com or go to electricalcodeacademy.com or go to masterthenec.com. You can find out more on our program to learn the NEC, whether you're preparing for an electrical exam or you're just wanting to get a better understanding of the National Electrical Code. Please do me a favor, go check it out. If you have any questions, we do have some demos and some tutorials that you can watch to learn more about our program. So give that a check out. And if you got any questions, feel free to reach out to us. All right, so on today's episode, this is number 4, and we've done 3 previous through the 2021. This is the first one in 2022. And we're going to be looking at some code questions and trying to dissect them to help you get more knowledge on the National Electrical Code. Okay, so let's go on and get started. And by the way, we will dig into the code book. So we will show you the code references that we use to come up with these answers. So it maybe will help you understand the NEC maybe just a little bit better. All right, so the very first question that we've got on the docket here is a question that wants to know what the general lighting load is and what is basically the connected value before we do any derating to it or apply any demand factors to it. So what is the lighting demand load or the actual lighting load for a house with outside dimensions of 30 by 48 on the first floor and 22 by 42 on the second floor? Okay, so I've got 2 floors. So we need to know what is our total square footage. All right, so fairly straightforward here. We'll give you the answer, then we'll go look it up in the code and see where we get these answers. All right, so the code is telling us that 220.11, which is new for the 2020 edition of the NEC, all the information in 220.11 used to be in 220.12. So it got moved out, and this just gives you the rules on how to come up with calculating your dimensions. Okay, so we can find out what the floor area is, square footage wise. So that's what 220.11 is. Now, where did that 3 VA for dwellings, or where did the dwelling information go from the 2017 to the 2020? Well, it used to be again in 220.12, and then the table, which was a general lighting table, used to say 3 VA per square foot for a dwelling. Well, that's no longer in the table anymore. It's been moved to 220.14J, and that's where it really needed to be because that was dealing with dwelling units. And this is obviously trying to calculate out the general lighting, which also, by the way, includes the general use receptacle. That's the receptacles that are in your bedroom, in the living room, basement, things like that. Those are called general use. So if you look at 220.14J, that's now where you're going to get the rules to be 3 VA per square foot. Okay, so that's what's going to be there. But before we even just kind of glance at the code book and kind of verify that, because again, you want to also make sure you verify it. Let's go on and get those square footage values while we're here. So 30 by 48 is 1,440 square feet. 22 by 42 is 924 square feet. Add the 2 together because it is 2 floors, by the way. And that would be 1,440 plus 924. That is 2,364 times 3. We're going to verify that. That equals 7,092. So our lighting connected value based on when we say lighting demand, that's because we applied the actual square footage using 3 VA per square foot, and that ends up being a demand load. Now, we haven't done any derating of that. We haven't applied any demands to that to potentially reduce that value. That's not what was asked here. We're just trying to find the lighting's demand, or its connected demand load at 3 VA per square foot. Okay, with that said, we need to go look at the code so we can quantify all that. We always want to verify. So let's go on and go to the code. And we're in the code, and we're obviously going to go to 220. So let's do that. I believe, yeah, we're already there. All right, so 220. All right. Now we're going to go down. And well, the first thing we want to look is at 220.11. So here's 220.11 right here. Now, this used to be 220.12 when it came to this how to do the dimensions, outside dimensions rule, but no longer here anymore. So 220.12 is specifically for non-dwelling occupancies, right? And so we're trying to determine the actual dimensions here of our dwelling that we just calculated. So it says the first for the floor area for each floor, and we had 2 floors, shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. It says for dwelling units, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces that are not adaptable for future use. An unfinished basement, you would add that floor area because that is obviously unfinished space, but it is adaptable for future use. So you have to account for that floor area. That way, when somebody does finish off the basement, for example, then the general use and general lighting, general use receptacles and general use lighting already covered. You don't have to add anything else for those. Okay, so they're already in there. Example of a space that would not be adaptable for future use might be an attic that you access through a scuttle hole. It's not designed to support weight anyway, so it's not really adaptable for any future use, so I don't have to take that square footage into consideration. So that's 2 extreme ends of the spectrum there. A basement that is unfinished is most certainly adaptable. An attic that's only accessible through scuttle, for example, it's not designed to support loads, is not adaptable for future use. Okay, so kind of give you some examples. So we've already kind of done our measurement. And so you'll notice that in table 220.12, that dwelling is no longer there anymore. This is purely for use in non-dwelling applications. All right, so we're going to go down to 220.14J. That is for dwelling units. And we're going to kind of look at this, and I'm going to give you probably more information than you need since the question was only asking about the lighting loads, but I'm going to give you more than you probably want. So 220.14J for dwelling unit, it says, in 1 family, 2 family, and multifamily dwellings, the minimum unit load shall be not less than, and we're going to use 3 VA per square feet. Okay, the lighting and receptacle outlets specified in 220.14J1, J2, and J3 are included in the minimum unit load of 3 VA per square foot. Okay, now it says no additional load calculations shall be required for each outlet. Okay, so we'll kind of look at these in a second, but that's it. It says the minimum lighting load shall be determined using the minimum unit load and the floor area as determined in 220.11, which is right here. And we already did that on our previous slide. Okay, so we're good there. All right, now let's look at 1, 2, and 3 real quick. I told you I was going to give you more than you probably needed. It reminds you, in case anybody ever asks, what rule tells me that that 3VA covers not only the general lighting, but also covers general use receptacles? All right. Well, number 1 does that. It says all general use receptacle outlets of 20 amperes rating or less, including receptacles connected to the circuits in 210.11C3 and 210.11C4, which is the bathrooms and the garages if you have it. What it means is they're already figured into the 3VA. I don't have to take 1500 VA like we do for the laundry and like we do for the small appliance brand circuits. Okay, those aren't general use. But the general use stuff is already covered in that 3 VA per square foot. So we're already taking care of those. Next, it goes on to say the receptacle outlets specified in 210.52E and G. So the garage is taken care of. Those receptacles, the 210.52E already taken care of. And if you want to look at those, we can go look at them. I can click 210.52 and you can see these are their outside receptacles right here. That's the one that you would have at the front, in the back of a dwelling, already taken care of in that 3 VA per square foot. And of course, if you wanted to see the G, then we could go look at the G just so you can look at it. I know a lot of people like to see all those things. So 210.52G, as I scroll down to it, right here, there's AV 52, A, B, C, D, E, F, G. Right here. Again, the basements, okay, garages and accessory buildings already figured into that. Okay, so the loads are already there. Don't have to add anything additional for that. Okay, all right. So just wanted to make sure that we knew what we were covering. All right, back to where we were. All right. So then it also says that, you know what? All those lighting outlets that are required by 210.70, okay? The lighting in the bathroom, the lighting in the kitchen, the lighting in the laundry, the living rooms, and our lightings in other areas of the code that would require the lighting, already covered. Okay. Now, of course, that we're allowed to switch receptacles in some areas other than bathrooms and kitchens. We're able to switch a receptacle in lieu of a lighting outlet. Those are in the rules there that we've covered in other episodes. But for the most part, all of our general lighting that's covered in 210.70 is, guess what? It's already figured in for that 3 VA per square foot. So I don't have to do anything special for that when it comes to that lighting. Again, the lighting that's in 210.70. If the lighting you're adding is not covered in 210.70, then that's additional lighting, and we're going to have to add that value in because that is an additional lighting. That's not what's covered under 210.70, okay? And you've got all these other rules up here that give you some guidance on that. Again, all other loads right here, all occupancies, okay? Say you've got some rules here, and if it's a specific appliance or load, you're going to take that value and add it to the calculation, okay? All right. So anyway, we got all that covered. All right, so now that's where we get all of our values to use the 3 VA per square foot. So again, wanted to make sure I wrapped all those up so that you knew what's all included in that. All right, let's go back to our question. So we should be pretty clear on this one. I gave you probably more than you needed, but anyway, it's good to have a little more than the normal. All right, next question. We have 4-unit apartment, has the following electric ranges. So it's a 4-unit complex. It's got a 15 kW, we got a 14 kW, it's got a 10 kW, it's got a 9 kW. And we're trying to calculate the service value, overall value for this building with these 4 different ranges. Now the question only wants the range contribution for this building, okay? So we're gonna have to figure out how to do this, okay? So first things first, in this case, before we look at the answer, we're going to go to the code book in this case and look at the code and work through this one and try to look at the different pieces before we plug it all in. So it's better to work it that way. All right, so I'm going to go to the code. And in the code, we're going to go on down to 220.55 right here. And we're going to read this code rule first, and then I'll show you how to dissect this out so you understand it a little bit better. All right, 220.55, it says, electric cooking appliances in dwelling units and household cooking appliances used in instructional programs, okay? So that would be like a home ec maybe at a high school or something like that for its instructional program. They typically do use like a household ranges for those type of applications. So that's what this table is all about. Not for commercial appliances. You know, that's going to be different, right? So that one you're going to be looking at right here. Kitchen equipment and other than dwellings, 220.56. So we're talking about very much an apartment complex. We're talking about dwelling applications. We are very much going to be in 220.55 here. Okay. So again, the question was only dealing, however, with the range value. So let's kind of work this out. All right, so we got to read it to find out what it means. The load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW, meaning that any of them that are 1 3/4 or less, you still would add that load. Okay, and that was where we saw in 220.14a, and you still have to account for that load, for that specific load, right? And then typically it's going to be whatever the kW value is of that load. However, you're permitted when it is over 1 3/4 to apply the demands that are in table 220.55. Okay, so remember that. But in our case, all of ours were over 1 3/4. So let's just keep on plugging away. It shall be permitted. So that's a permissive statement because you could take it at the full value and you're going to end up with a service larger than necessary. So we're probably always going to use where it says shall be permitted. We're going to use the permissive rule. Now, it says shall be permitted to be calculated in accordance with table 220.55, which is right here. Kilovolt amperes, which is kVA, shall be considered equivalent to kilowatts, that's in kW, for loads calculated under this section. So under section 55 of Article 220, if I have 50 kVA, it's the same as 50 kW. If I have 50 kW, it's the same as 50 kVA. And of course, I like to work everything in VA because ultimately at the end, that's what we're going to work it in. But just it reminds you that they're equal. Okay, no big deal there. Now let's look at the table. The table says, Table 220.55, demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances that are over 1 3/4 kW rating. Then it has this all-powerful parenthesis. It says, column C to be used in all cases, except as otherwise permitted in note 3. Now, for our case, you looked at our question earlier, we're not going to be using note 3. But while we're here, we might as well look at note 3. And note 3 says, well, if your cooking appliances are over 1 3/4 kW through 8 3/4, which ours are all over this anyway, then in lieu of the method provided in column C, which remember, it said you always go to C unless you're permitted by note 3. So if they fall within 1 3/4 and not more than 8 3/4, then this note can be utilized. Then basically what you do is you take the nameplate ratings of the household cooking appliances that are rated more than 1 3/4, but not more than 8 3/4, and multiply the sum by the demand factor specified in column A or column B. So if your cooking unit falls in A and you only had 1, you would take it, the nameplate, multiply it by 80%, and that's your value. If it falls under B, it means it's between 8 and 3.5 through 8 3/4. And if it's 1, then it would be 80%. If you have two different units like an oven and a cooktop, and one falls under A and one falls under B, then you would apply each column individually and then add them together. Now, the one thing about note 3 is that once you do that and you use A and B or both, you still have to compare it against column C, okay? And whichever results in the lesser value, you get to take that value, okay? So C, you still always have to compare to, okay? All right, now in our case, we're not going to use note 3. However, we know that we do have some what? We do have some ranges that are over 12 kW. Okay, because of that, we're going to look at the notes. See, it says C notes. Now, we're not going to use note 1 because even though our ranges do fall between 12 and 27, right? The problem is we have some that are less than 12, and all of the ranges are not equal. They're not all the same rating, okay? They're unequal. So we're going to look at note 2. Note 2 says as long as they're over 8 3/4 through 27, and the ranges are unequal value. Now, all of ours were unequal value. So we're firmly in note 2. So let's look at this, and then we'll see how this applies. It says for ranges individually rated more than 8 3/4, and all of ours are, and of different ratings, which they are, it says, but none of them exceed 27 kW, which none of them do. It says an average value, okay, an average value of the ratings shall be calculated by adding together the ratings of all the ranges, and we have 4 of them, to obtain a total connected load using 12 kW for any range that's rated less than 12. So what is that telling us? In our case, we had 2 ranges. One was 9 kW and one was 10, both of which are less than 12. So this rule is saying do what? Forget that it's 9 and forget that it's 10. Draw a line through it. Make them 12 kW. So that's what it says to do. And once we do that, then we add them all up, and then we divide that total value by the number of ranges that we have, which we had 4 of them. And that's going to become our average. Now, once we establish that average, we have to look and see how many kW is that average over 12 kW. And that's what it says in this last line. It says when the maximum demand in column C is used, it says then the maximum demand in column C shall be increased 5% for each kilowatt or major fraction thereof by which the average that we just computed, okay, exceeds 12. Okay, Let me show you how that works. In case you're saying, I don't know what you just said, Paul. I need you to show me on paper what you just said. Okay, no problem. We're going to show you. All right, so let's go on and work this out and show you the workout equation. All right, so this is what we've got. So let's kind of work through this and follow what the code just told us to do. All right, so the answer we know is 17.85 kW. We have that note that's reminding us to use 12 kW for any range that was less than 12. And in our case, we had one that was 10 and one that was 9. So we're going to strike through those and make them each 12. So step 1, 15 plus 14. And now instead of 10, we're using 12 plus 12. And then the 9 is now 12 plus 12 again. That's 53. Now, what did it say? That is the total connected kW for these 4 ranges. Now we want to divide that by how many? 4, because we had 4 ranges. Remember what the rules in note 2 said. So that would be 53 divided by 4. That is 13.25. Now remember, that's our average now. Remember what the note said. It said you must increase it 1 kW. That's whatever the demand value is in column C. Must be increased by 1 kW for every kW that exceeds 12, or major fraction thereof. Okay, major fraction. So 0.25 is not a major fraction. 0.5 and greater would be a major fraction. So in this case, 13.25, you drop the 0.25, it's just 13. So it exceeds 12 kW by 1 kW. And it said you increase the value now in column C, 5% for every kW that exceeds 12 kW. See, I think what happens here is people get confused. The exercise that we did at the beginning was just to take all of those ranges and find an average. Once we find that average, then we apply the 5% for every kW that exceeds 12. Once we find out what that percentage is, we're done with that. Now we got to go back to column C in 220.55, and then we go down and see, okay, 4 ranges. What is the demand value for 4 ranges in column C? That was 17 kW. Now we apply that 5%, remember, which was what? It was 1 kW over 12 because our average was 13 kW. So we just did that exercise so we can find out what our percentages we have to use. Okay? So we take that 17 and we multiply that by 5%. So 5% of 17 is 0.85. There's another way to do this. You could go 17 times 105% because the 100% represents the 17. The 5% represents trying to achieve the 5% of that 17. Okay, so either way you want to do it, doesn't really matter. It comes out to the same value. So 17 times 5% is 0.85. So you increase the value in column C by 5% of that value in column C, which was 17 kW. So 17 plus 0.85 is 17.85 kW, and that's the contribution to our service for these 4 ranges. Pretty simple, right? Okay, there we have it. And again, remember, this one was just talking about ranges, okay? Not doing something like we can do when we have multifamily dwellings and we're doing those rules. This is just an example of how you would calculate it for just the ranges, okay? We don't know any other variables to do anything other than what we've just done, okay? All right, so that's that question. And then we'll move on to the next question. So the next question is dealing with a motel. And it says, a motel has 50 guest rooms. Each room measures 18 feet by 30 feet. It reminds us that each room contains 8, well, it doesn't remind us, it tells us. Each room has 8 duplex receptacles, of which one of those are GFCI protected, as if that we care about that, because again, we got to know what the question's asking us. It says, what is the general lighting and receptacle load after demand factors for guest rooms in this motel? Now, this is very similar to what we kind of did with the dwelling unit application, because 220.14m is telling us that those general use receptacles and that general use lighting is all going to be covered in that VA per square foot value. But in dwellings, it was 3 VA per square foot. In motels and hotels, it's not 3 VA per square foot. It's a different value, okay? So we're gonna have to go look at that. But there's a couple things that we can knock out right now while we're here. And the first thing is we need to find out what our total square footage is so that we know how to apply the values that are in 220.12, remember? Because that table is for other than dwelling applications in case we're doing a motel. So we're gonna use 220.12, but I need to go on and do some work first. So the first thing I wanna do is, let's go on and find what the square footage is for one room. And that one room is 18 by 30. So I'm going 18 times 30, and that is 540 square feet. Now we've got 50 of them. So I'm gonna take that 540, I'm gonna multiply that by 50, and that is 27,000 square feet. Okay, so that's what the total square footage is that we have for these guest rooms in this motel. Okay, so you can just write that down. Now we got to go look at the code. Okay, so now we're going to go look at the code and see what we have to do. So I'll take you over to the code. And we are off of this part of it now, so we got to go back up to 220.12. And here is your general lighting loads for 220.12. And we're looking at hotels and motels right here. So that tells me that it is 1.7 is our VA. Now, for those that ask, you say, Paul, doesn't that say just general lighting load? Yeah, but the question had general use receptacles as well. Well, remember I said it's very similar to what we did in 220.14J. I'll go on and show you it real quick. That 220.14M is the same concept for hotels and motels. All this language right here reminds you that those general use receptacles, just like it did before, those outlets that are required in E3 for the outside receptacles and the lighting outlets in 210.70, all of that is already covered in that specific VA per square foot, which was 1.7. It's already covered. Okay, so in our question, it didn't matter whether there was 8 receptacles and one of them was GFCI. It's irrelevant. That's not what's being asked. Those receptacles anyway are included as part of the 1.7 VA per square foot. So again, we don't have to do anything for that. And where do you get that? Right here, it tells you that the lighting and receptacle outlets that are specified in 220.14 M1, M2, and M3, which are these we just talked about, that are very similar to what we just did, those are already included in the unit load that's in table 220.12, and that was that 1.7 VA per square foot. Again, it reminds us, no additional load calculations shall be required for such outlets, the ones we just talked about, which are right here, 1, 2, and 3. We don't have to do anything for those. So in the question, those 8 receptacles, they didn't mean anything to us. We didn't need that part of it, okay? All we cared about at this point so far is what? We need to find out that it is 1.7, okay? So that's the first thing we do. So let's go on and go back to our equation, or our question, rather. See what we need to do. All right, so we had 27,000, and we're going to take that times 1.7, and that is 45,900. So 45,900 at this point is our total volt amperes. Now, you notice the question says after demand factors are applied. So what does that mean? Well, let's go back to the code and you'll see what I'm talking about. All right, we're back into the code. And now what we're going to do is we're going to go down to 220.42. Now, here's what it says right here. 220.42, it says the demand factor specified in table 220.42 shall apply to that portion of the total branch circuit load calculated for general illumination. They shall not be applied to determine the number of branch circuits for general illumination. Okay, so we're just going to be applying the demand factors again for the general lighting. We, of course, know that also includes general use receptacles, but we're only going to apply it, again, it's all encompassing because 220.12 said general lighting, but we know that it also covers receptacle usage. That's just extra information. Right now, we're focusing on the illumination, okay? All right, so let's go down here. Now, you see hotels and motels right here, okay? All right, so it says first 20,000 or less, 60%. That, so you take that 20,000 of our value, which is 45,900. You take the 20,000 to the side and you multiply that by 60%. And then you have a remaining value of 25,900. So that 25,900 falls between the 20,001 to 100,000. So you apply 50% to that value, add the two together. And that would be your value after demand factors. Okay, well, let's go back and actually do that now that we know how that works. So we'll go back to our question and we'll apply these. All right, so here's what we got. We knew it was 540 square feet because we did 18 by 30. We knew there was 50 rooms, so that was 27,000. We did that. We went to 220.12. We got our value is 1.7. So that was 27,000 times 1.7, and that's where we got, we're 45,900 VA. Now we get to apply some demand factors, and that was in 220.42. It said the first 20,000, we can take it at 60%, which is going to be 12,000. So you take 20,000 times 60%, 12. The remainder over that, and it wasn't more than 100,000, so we take that remainder, and we get to multiply it, which was 25,900, at 50%. That ends up being 12,950. Well, guess what? We're going to add those two together. The 12,000 from the first one, the first 60% of the 20,000, and we're going to take the remaining value over that we did by what? That we did by 50%, and that was 12,950. Add them together, 24,950 VA, and that is our contribution for these, the general lighting and receptacle loads after we applied the demand factors in 220.42 to our application of this question. So hopefully you got something out of this that you felt like you, kind of helped you solve this equation. As always, we're here to teach you the National Electrical Code. Our fast track system is without a doubt the #1 system out there to teach you the NEC. Basically, we're going to check you at every stage to make sure that you understand the National Electrical Code with competency reviews. You get to join us on Wednesday nights. You get to ask your questions. There is no better system. We're going to help you move from the very first unit all the way to the end to help you understand the National Electrical Code, maybe not just to pass an exam, but maybe to be a more well-rounded electrician. So if you want more information, go to fasttracksystem.com or go to electricalcodeacademy.com or go masterthenec.com. You can find us out there. I'm sure if you Googled Fast Track System, you would find us. If you have any questions, please, by all means, we have a Contact Us button on our website. Feel free to reach out to me. I'm more than happy to answer any questions you have on the program. Also, we have tutorials on our program. Check those out under the mini courses on the tab on our website. You can ask us anything about our program. We're more than happy to explain it to you, folks. So, till next time, stay safe. God bless.